Okay, so the next question that we have is question number 7, where you want to write the middle terms of or the middle term. Question number 7, you want to find the middle term in the expansion of basically 3 minus x cubed over 6 raised to the power 7. Right? Okay, so you want to find the middle term in the expansion of 3 minus x cubed by 6 whole raised to the power 7. So the way that you can do it is that basically you know that in the expansion of a plus b raised to the power n, basically if n is odd, then there are two middle terms. We have already talked about this before. There are two middle terms which are basically n plus 1 divided by 2th term, and the next term after this, which would be n plus 1 divided by 2 plus 1th term, which means that since here n is equal to 7, the two terms would be basically 7 plus 1 divided by 2th term, and basically 7 plus 1 divided by 2 plus 1 term. This is 8 divided by 2 is equal to 4th term, and this is 8 plus 1 is equal to 8, but that would be 4 plus 1 is equal to the 5th term. So that means that you're looking actually for the 4th term and for the 5th term. So meaning that we are looking for A of, or T of, basically T of 4, for T of 4 and T of 5, right? Now at T of 4, R is equal to basically 1 less than the term number, which is equal to 3, and at T of 5, R is equal to basically 4. So now to find the 4th term, to find T of 4, we have, so basically the T of R plus 1, which is equal to T of 4, is equal to n combination R, a raised to the power n minus r, b raised to the power r. So at the fourth term r is equal to 3, n is equal to 7, a is equal to basically 3, and the other one is negative x cubed by 6. 3 and negative x cubed by 6, that is equal to b, right? 3 and negative x cubed by 6. Which means that then n combination r would be equal to basically 7 combination r, which is equal to 3. A raised to the power a is basically 3 raised to the power n minus r raised to the power 4. B raised to the power r, which is basically negative x cubed divided by 6 raised to the power r, which is equal to 3. Now here we have basically 7 combination 3, so I write this as 7 combination 3 raised to the power 4, and I can write this as negative x cubed raised to the third power, and 1 over 6 raised to the third power. I can write that as 1 over 2 times 3 raised to the third power, which I can write as 7 combination 3 raised to the power 4 negative x cubed raised to the third power, and I can write this as 1 over 2 cube times 1 over 3 cube, and then 2 cube, 3 cube, and 4 cube. So I can simplify this. I can write the 3 over here. And so I can write basically 7 combination 3, which is basically 7 combination 3 is the same thing as 7 factorial by 4 factorial by 3 factorial, which is equal to 4 factorial times 5 times 6 times 7 divided by 4 factorial times 6. 4 factorial and 4 factorial I can cancel out. These two I can cancel out. I can write this as 5 times 7 is equal to 35. 35 times, you have 35 over here. You have 35 times 3 divided by 2 cubed, which is equal to 8. And then you have a negative sign over here as well. I write the negative sign outside. And then this is x cubed. X cubed raised to the third power is equal to x raised to the power 9. So this is already taken care of. This is taken care of. And this is also taken care of. And that means that you have 3 times 35 is equal to 90. 1505. Negative 105 divided by 8. X raised to the power 9. That is equal to t of 4. T of 4. That is one of the terms. So negative 105 divided by 8, x raised to the power 9. And in the same way we can calculate t of 5, right? So t of 5 would be equal to, so now to calculate t of 5, we have basically t of 5, which is equal to t of r plus 1, is equal to n combination r, a raised to the power n minus r, b raised to the power r. And so here basically your r is equal to 4, your n is equal to 7, if I'm not mistaken. N is equal to 7, a is equal to 3, and b is equal to negative x cubed raised over basically negative x cubed over 6. Therefore, this is equal to n combination r, which is 7 combination 4. 7 combination 4. A, which is 3 raised to the power 7 minus 3 cubed, that would be, and negative x cubed by 6 raised to the power 4. Raised to the power 4. So that would be basically 7 combination 4, 3 cubed, and I write this as x raised to the power, basically negative raised to the 4th power is positive, x cubed raised to the 4th power is x raised to the power 12, and 1 over 6, I can write 1 over 6 raised to the power 4. I can write it as 1 over 2 times 3 raised to the power 4, and then I can write it as 1 over 2 raised to the power 4 times 1 over 3 raised to the power 4, right? So I can write it as 1 over 2 raised to the power 4 times 1 over 3 raised to the power 4. Which means that I have basically 3 raised to the power 4. You get a 3 over here, and 7 combination 4 is the same thing as 7 combination 4 is the same thing as 7 factorial, 3 factorial, 4 factorial. So that's the same thing as 4 factorial times 5 times 6 times 7. Divide that by 3 factorial, which is 6 times 4 factorial. These two can cancel out. These two can cancel out. That's 5 times 7, which is equal to 35. So that's the same thing as 35 divided by 2 raised to the power 4 is equal to 16. 16 times 3 is equal to 30 and 48. X raised to the power 12. And I think you can divide by nothing really. So the other term, which is basically, this is T of 5. T of 5 would be this term over here. And 35 by 48, x raised to the power 12. Okay? These are important things that you need to be able to do. Okay, you need to basically pay attention to the process and learn it, because no matter where you go in mathematics or anywhere else, you are going to need all of these. So don't do these carelessly. Pay attention to them. Okay, so that was question number 7. Question number 7. Question number 8. We have, okay, so the next question that we have is that you want to find the middle term of question number 8. You want to find the middle term of basically x divided by 3 plus 9y all raised to the power 10. Okay, so since basically in the expansion of basically a plus b, in the expansion of a plus b raised to the power n, if n is even, then the middle term is given by n divided by 2 plus 1 plus 1, meaning that meaning that the middle term is the n divided by 2 plus 1th term, right? Is the n divided by 2 plus 1th term. Now, since n is equal to 10, n divided by 2 plus 1 is equal to basically 10 divided by 2 plus 1 is equal to 5 plus 1 is equal to 6. So we are looking for the 6th term of the expansion. We are looking for the 6th term of the expansion, meaning that we are looking for t of 6. Now at t of 6, or you can basically say that basically t of 6, which is equal to t of r plus 1, is equal to n combination r, a raised to the power n minus r, b raised to the power r. And so at this term, your r is equal to 5, your n is equal to 10, your a is equal to x divided by 3, your a is equal to x divided by 3, and your b is equal to 9y. And therefore this would be equal to basically 10 combination 5, a, which is x divided by 3 raised to the power 10 minus 1 is equal to 5, and 9y raised to the power 5, which is the same thing as basically 10 combination 5, x raised to the power 5, x raised to the power 5, 1 over 3 raised to the power 5, 1 over 3 raised to the power 5, 1 over 3 raised to the power 5, and then you have 9 raised to the power 5. 9 raised to the power 5, I can write it as 3 squared raised to the power 5, which is equal to 3 raised to the power 10. So that's 3 raised to the power 10 and y raised to the power 5. So then I can write this as 10 raised to the power 5. So this you get 3 raised to the 3 raised to the power 5, 3 raised to the power 10. You'll get 3 raised to the power 5 here. And 10 combination 5 is the same thing as 10 factorial, 5 factorial, 5 factorial, which is equal to basically 5 factorial times 6 times 7 times 8 times 9 times 10 divided by 5 factorial times 5 times 4 times 3 times 2. 5 times 2 is equal to 10. 5 factorial and 5 factorial can cancel out. 4 and 2, 3 and 2. So you have basically 14 times 18. 18 times 14, 32. 4, 72, 0, 18. So you have 2, 15. 15, 252. You have 252, divide that by times 3 raised to the power 5. 3 raised to the power 5 is equal to 81 times 3. 81 times 3, which is equal to 243 times 243. And then multiply that by x raised to the power 5, y raised to the power 5. And so you will have basically 243 times 252, which is the same thing as 2 times 3 is equal to 6, 2 times 4 is equal to 8, 2 times 2 is equal to 4, 0, 5 times 15, 1, 20, 21, 10, 12, 0, 0, 6, 8, and 4, 6, 13, 1, and 6 plus 6 is equal to 12, 1, 10, 11, 1, and 6, 6, 1, 2, 3, 4. So that is 6, 1, 2, 3, 4, x raised to the power 5, y raised to the power 5. That is your middle term. That is your middle term. That is basically t of 6. That is t of 6, which is the middle term. That is t of 6, which is the middle term. Okay, so let me find the answers here. Okay, I think there is something wrong here with this calculation. Let me calculate 252 times 243, that's 61 to 36. That's actually supposed to be 61 to 36. And that would be then the correct answer. So everything is right except for this last step that we made a mistake, but otherwise everything is right. Okay. Now the next question is, okay, so the next question is a bit of a unusual question, but well, unusual questions exist as well, and you learn something in this solution, of course. Otherwise I wouldn't solve it, because I really didn't understand the question, I mean, completely. But then you would actually you would actually learn something in the question, meaning that, and I'll tell you what I mean by that. So the question is, in the expansion of 1 plus a raised to the power m plus n, prove that the coefficients of a raised to the power m and a raised to the power n are equal. Okay. So now the way that you can prove this, now of course it doesn't really matter whether you prove it or not. That's immaterial, right? But then basically but then the solution is that basically it is known that r plus 1th term, or t of r plus 1, of course we know that, or you can say it is known that basically r plus 1th term, or r plus 1th term, or t of r plus 1, or t of r plus 1 in the expansion of in the binomial expansion of basically a plus b raised to the power n is given by basically t of r plus 1, which is a general term, is n combination r a raised to the power n minus r b raised to the power r, right? That we already know from the binomial expansion of a plus b raised to the power n. Now here we are talking about a raised to the power m and a raised to the power n. And well, of course you can make all kinds of assumptions as long as your assumption is sound. And it's a sound assumption to assume that a raised to the power m, that it occurs in some term. That it occurs in some term. I mean, well, you can make that assumption, of course. But I suppose if you make an assumption, even if it's not a sound assumption, then you will essentially come to some sort of contradiction, which would basically tell you that your assumption was wrong. So as long as you're making assumptions, you can make all kinds of assumptions, but then you need to be careful about contradictions, right? So you can assume that, assuming that, for example, a raised to the power m occurs in the r plus 1th term, of the expansion of basically 1 plus a raised to the power m plus n, we obtain basically t of r plus 1. T of r plus 1 is equal to n combination, well, here we wrote n combination r, a raised to the power n minus r, b raised to the power r. That means that then over here your n would be m plus n, combination your r would be basically 1 less than this number, which would be r, and then a raised to the power n minus r, which is a in this case, is 1. So 1 raised to the power m plus n minus r, and then b raised to the power r, which is basically b raised to the, so you would have basically a raised to the power r, right? So that would be the same thing as m plus n combination r, a raised to the power r, right? Now we made the assumption that this would occur in the r plus 1th term, and the r plus 1th term is given by this formula, which means that so we assume that basically this a raised to the power m would occur in this term, which means that, so you have a raised to the power m, and over here you have a raised to the power r, which means that m is equal to r, right? So that implies that m is equal to r, right? So, or r is equal to m, which is the same thing. And therefore the coefficients of a raised to the power m, and therefore the coefficients of a raised to the power m would be basically so you have a raised to the power m here. This you can think of this as a raised to the power m, and the coefficient. And so if m is equal to r, so then this r would be also m. So m plus n combination m plus n combination m, right? Which is the same thing as basically, m plus n factorial, m plus n minus m factorial, minus m plus n minus m factorial, minus m factorial times m factorial, which is the same thing as m plus n factorial divided by n factorial times m factorial, right? Now, you can make the same assumption again for a raised to the power, for basically the other term, which is a raised to the power n, meaning that you can assume that a raised to the power n occurs basically in k plus 1th term, of the expansion of 1 plus a raised to the power m plus n. So then we have so the k plus 1th term of that expansion would be t of k plus 1, which would be the same thing as, well, normally you have basically, if you have t of r plus 1, you have basically n combination r, a raised to the power n minus r, b raised to the power r, right? So that means that here you have m plus n combination r, which is basically r would be less than the term number, which is combination k, a raised to the power m plus n minus k, b raised to the power k plus 1, right? Which is the same thing as m plus n combination k, a raised to the, so a over here is equal to 1, so 1 raised to the power n plus n raised minus k, and b is a, so a raised to the power basically k plus 1, right? So what that means is that then you can write this as m plus n combination k times a raised to the power k plus 1. And I'm writing this way because 1 raised to any power is just 1. Now here we said that a raised to the power n occurs in, assume that basically a raised to the power n occurs in this term. That means that n is equal to k plus 1. It means that a is equal to k plus 1. N is equal to k plus 1. Which means that basically k is equal to n minus 1. Which means that k is equal to we made a mistake here actually. No, we made a mistake here, I'm sorry. So that's m raised to the power m plus n raised to the power k, 1 plus also a raised to the power k actually. That has to be k and k. So you have t of k plus 1 would be equal to m plus n raised to the power m plus n combination k, a raised to the power m plus n minus k, b raised to the power k, right? So you have m plus n combination k, 1 raised to the power n plus n minus k, and then you have a raised to the power k. And so that's the same thing as m plus n combination k, a raised to the power k. Now if you compare a raised to the power k and a raised to the power n, since we made the assumption that a raised to the power n occurs here, we can conclude that basically n is equal to k. Which means that basically, in which case basically I can write the same thing as m plus n combination n, a raised to the power n. So the coefficient of a, so therefore the coefficient of a raised to the power n is m plus n combination n, which is equal to m plus n whole factorial. This is combination n. M plus n whole factorial, m plus n minus n factorial times n factorial, which is the same thing as basically, m plus n whole factorial divided by m factorial divided by times n factorial. So the coefficient of a raised to the power n is equal to m plus n whole factorial, n factorial, n factorial, and the coefficient of this of a plus I of a raised to the power m is m plus n factorial, n factorial times n factorial. And therefore we have proved that the coefficients of a raised to the power m and a raised to the power n in the expansion of 1 plus a raised to the power m plus n, if I'm not mistaken, 1 plus a raised to the power m plus 1 plus a raised to the power m plus n are both equal to m plus n combination, are both equal to basically m plus n factorial over m factorial n factorial, and therefore equal. Right? So that's basically this question here. That was question number 9. Now, the next question is question number 10. Is question number 10. Okay, so question number 10, we have basically the coefficients of the r minus 1th term, rth term, and r plus 1th terms in the expansion of x plus 1 raised to the power n are in the ratio 1 to 3 to 5. You want to find n and r. Okay, so you have basically the coefficient of, let's define the coefficient of the nth term as basically, for example, as c of, for example, c of n, for example, c of nth, for example, something like that, anything. It's just as long as you know that c of basically n is equal to, is the same thing as the coefficient of the nth term, then everything is okay. Now so what we are saying is that the coefficient of r minus 1th term, which is c of r minus 1, and this is not combination of this, of course you know what that is, the coefficient of r minus 1th term and the coefficient of basically the rth term and the coefficient of the r plus 1th term, they are in the ratio of some expansion x plus 1 raised to the power n are in the ratio 1 to 3 to 5, right? So and then now what you want to do is that you want to find n and r. So basically what you need to do is that you need to find the coefficient of the r minus 1th term, the coefficient of rth term, the coefficient of r plus 1th term, and then you will get two equations. Solve those two equations, you will get basically n and r, right? So to find the coefficient of the r minus 1th term, we have, so the coefficient of r minus 1th term, or basically to calculate the r minus 1th term, that would be t of r minus 1, and t of r minus 1 would be equal to 1 less than, basically r at this term would be 1 less than the term number, which is basically r minus 1 minus 1, which is equal to r minus 2. So your r would be r minus 2, which means that then you have basically, and the general form of the formula is n combination r, a raised to the power n minus r, b raised to the power r, right? Which means that you can write over here n combination, and at this term we said that your r is equal to r minus 2, a combination n minus r plus 2, b raised to the power r minus 2, right? Now over here, what we have is that basically we are talking about this binomial expansion, in which case n is the same thing as n combination r minus 2, and your a is equal to x, for example. Your x is equal to x. You can of course take it as 1 plus x, would be easier. So then your a would be equal to 1, and you have n minus r plus 2, b raised to the power, so x raised to the power r minus 2, right? That would be equal to n combination r minus 2, so this is 1, and then x raised to the power r minus 2. This is t of r minus 1. This is t of r minus 1, which is equal to n combination r minus 2, x raised to the power r minus 2. To calculate t of r, and of course you note that basically to calculate t of r, we have the following, and you calculate that the coefficient of t of r minus 1 is n combination r minus 2. So that is our coefficient here. So here the coefficient is, here our coefficient is equal to n combination r minus 2. So we have, okay, so to calculate t of r, we have basically t of r is equal to, basically our n here is equal to n, so basically our 1 plus x raised to the power n, right? So you have n combination, basically 1 less than the term number, so r minus 1. A over here is 1 raised to the power n minus r plus 1, and b raised to the power r, which is this r over here. So x raised to the power r minus 1, right? So this is equal to n combination r minus 1. This is just 1, so that's x raised to the power r minus 1. Right? So that means that here your coefficient means that over here your coefficient is equal to n combination r minus 1. Now, to calculate t of r plus 1, this is the coefficient of, to calculate t of r plus 1, to calculate t of r plus 1, we have so to calculate t of r plus 1, we have t of r plus 1 is equal to, well, again, we have the same story, n1 plus x raised to the power n. So you have n, which is the same thing as n combination 1 less than this, which would be r, 1 raised to the power n minus r, b raised to the, x raised to the power r, right? Which is the same thing as n combination r. This is just 1 x raised to the power r. Which means that over here, your coefficient is equal to n combination r. So based on what we have written here, the coefficient of r minus 1 to the coefficient of r to coefficient of r plus 1 is 1, 2, 3 to 5. Which means that n combination r minus 2 to n combination r minus 1 to n combination r, n combination r minus 2 to n combination r minus 1 to n combination r is equal to 1, 2, 3 to 5. Okay? And now you have something to solve. So to solve this equation, you can, for example, take n combination r minus 2 to basically n combination r minus 1, that is equal to 1 to 3. Okay? And you can solve this. It's now simple, so you can write it as n factorial n minus r minus 2 factorial divided by r minus 2 factorial, and divide that by n factorial divided by n minus r minus 1 factorial, r minus 1 factorial. That is equal to 1/3. N factorial and n factorial you can cancel out, and then you have to write this divided by this, meaning that you have to write this as basically n minus r minus 1 factorial times r minus 1 factorial, r minus 1 factorial, divided by this expression here, n minus r minus 2 factorial times r minus 2 factorial is equal to 1/3. Now to solve this part, so we argued before that n minus r minus 1 factorial over n minus r minus 2 factorial, if you want to simplify that. So if you have basically n minus r minus 1 factorial, divide that by n minus r minus 2 whole factorial, that you can write it as, so first basically you can say that basically n factorial is the same thing as 1 times 2 times 3 times all the way up to n, and over here you have n minus 1, and over here you have n minus 2, and over here you have n minus 3, and so on and so forth. And over here you can write this as n minus 0, which means that as you're moving in the direction left towards 1, this number over here, regardless of this negative sign over here, this number over here, you're adding 1 to it and you get to the previous term. Adding 1 to it, you get to the previous term. That means that you add 1 to r minus 1, you get r, which is of course not going to help me because I just want to somehow basically I want to somehow cancel these two out, meaning that I want to write this as 1 times 2 times 3 times all the way up to, for example, n minus r minus 1. And over here I have the same thing, 1 times 2 times 3 times all the way up to n minus r minus 2. If I add 1 to this number, I get r minus 1. So the previous term to this would be n minus r minus 1. And that would be exactly what I need here, because now I can simplify all of this with all of this. And so I get n minus r minus 2 in the denominator. N minus r minus 2. Which means that I can simplify this with this. And I get n minus r minus 2 here. And that is basically one thing that I can do. To simplify the two. Moreover, what I can do is that I have r minus 1 factorial over r minus 2 factorial. And these things, at least until you get comfortable with them, well, I had always this dream in my mind. I went to school in India. I went to a college in India, a very good college in India. And what I saw was that basically all of these students in the classroom were doing mathematics really fast. So, but of course, well, back then I was already 29 years old and they were 16, 17. Although I don't really know if age is much of a factor. I don't really know that, because that should be considered on the basis of the individual. Some individuals are very bright when they are even 7 years old. Some individuals are very they cannot think clearly even when they are 16 years or so. There is no way to tell that, to say that. But I had always this dream in my mind that I always wanted to do mathematics like these people, and it never actually worked out for me. I mean, even right now, if I want to do mathematics in my mind, I make mistakes. I don't have that kind of mind, at least not right now. And therefore, I don't try to do that. So I have to, basically, when I want to solve something, I have to write it down on a piece of paper. I have to do it step by step logically. Sometimes I have to write down every step until I get to the answer. Okay? So, which means that basically, if you're not fast, you don't have to get disappointed or anything, because you're not a computer, right? Being fast, I mean, computers are fast. But computers don't have intelligence. They're not human beings. You are a human being. Now, the way that you do mathematics is another completely different matter. Some people are fast in mathematics, some people are not, but everybody can learn mathematics because it's a simple thing. Step by step, you do something logically and you get to the answer, right? So that's for sure. Anyone can do mathematics, provided that they learn the basics from the very beginning. But whether or not we can do it fast, that's not even important, because you're not a machine, right? Now, some people can do it fast, that's very good. I wanted to do that actually, but now, well, now that I realize that I can't do that sort of thing, so I'm fine with that. And of course, it doesn't make any sense for me to compare myself to a machine, right? So, or to any other person for that matter. So it just doesn't matter whether I can do it fast or not. The important thing is that you basically take your time, go through the problem step by step, and then over time, of course, you get better and better in mathematics. But over time means over a long period of time. Probably, I don't know, at least 5 years. So that's basically that. Now, r minus 1 factorial over r minus 2 factorial, again, you can write over here. So if I add 1 to this number, so I have 1 times 2 times 3 all the way up to n minus 1. Add 1 to this number, I get n minus 2. If I expand this, I can come all the way up to n minus 2. And so I can cancel these two out, and I'll be left with n minus 1 in the numerator. So I will be left with n minus 1 in the numerator, which means that basically, n minus 1 divided by n minus r plus 2, n minus r plus 2 is equal to 1/3, which means that basically 3 times this, which is 3n minus 3, is equal to n minus r plus 2. Now 3n minus 3 minus n plus r minus 2 is equal to 0, which means that 3n minus n is equal to 2n plus r. Negative 3 negative 2 is equal to negative 5 is equal to 0. That is one equation that you will have here. Okay. One more equation that you will have here is that if you write, basically use the same basically thing here, the coefficient of the rth term to the coefficient of r plus 1th term is 3 to 5. So the coefficient of the rth term is basically n combination r minus 1, n combination is equal to n combination r minus 1 to the coefficient of the r plus 1th term. R plus 1th term is n combination r, is equal to 3 to 5, if I'm not mistaken. 3 to 5 is equal to 3 to 5. In other words, you can say n combination r minus 1, divide that by n combination r, that is equal to 3 to 5. And now you can solve this one as well. But before we go through this one, I will end this video. I end this video here, and then we will continue in the next video. Thank you.